Okay, now we're going to talk about properties of sequences. There's a whole bunch of formulas here that are on your formula sheets. I'm going to go through these and show you how they work. Here's the first four. So we're going to let A sub n and B sub n be any two real sequences and C be a real number. Then the sum from k equals 1 to n of the c's. Okay, what that means is C plus C plus C plus dot 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 plus C n times. So pretty sure you all know that if I take the same number C and I add it up n times, that's just C times n. Okay, so for example, if I took the sum from k equals 1 to 5 of the 3's, this would just be 3 plus 3 plus 3 plus 3 plus 3, which would be easily written as 5 times 3, which is 15. Okay? Now this next one, the sum from k equals 1 to n of the c times a sub k's. So this would be c times a sub 1 plus c times a sub 2 plus c times a sub 3 plus dot 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 plus c times a sub n. Now all of these terms have something in common. They all have c's in common. So I could factor out that c, and I get c times a sub 1 plus a sub 2 plus a sub 3 times dot or plus dot 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 plus a sub n. And this part right here is just the sum of the a sub k's. So this would become c times the sum from k equals 1 to n of the a sub k's. So essentially, all I did was I took this c that's right here and I factored it out on the outside, and I can do that. So if I have something like find the sum from k equals 1 to 4 of the 3k's, I can take out that 3 and just find the sum from k equals 1 to 4 of the k's. So that would be 1 plus 2 plus 3 plus 4. That would be 10. So this would be 3 times 10, which would be 30. Okay. Next, the sum, these two are actually the same thing, and I'm only going to do one of these. Okay. The sum from k equals 1 to n of the a sub k plus b sub k's. What I get to do here is I get to break this apart, and this is going to be equal to the sum from k equals 1 to n of the a sub k's plus the sum from k equals 1 to n of the b sub k's. And it works the same way for the subtraction one, except there's a minus sign in there. Okay, so what this would mean is if I had something like this, the sum from k equals 1 to 100 of the k squared plus 2k's, I can break this apart and find the sum from k equals 1 to 100 of the k squareds, and then add to that, I got 2 here. Remember, I can factor that out like I did up here. So this would be 2 times the sum from k equals 1 to 100 of just the k's. And we'll learn how to do this in a minute. But this is easy to find. This is easy to find. This, not necessarily easy to find. So it's a nice little theorem that helps me break this into parts that are much more usable.